With school coming back to in-person learning post-COVID, a lot of students are finding themselves in a difficult position. They got used to the online and visual learning that was present and very prevalent during COVID, and are now falling behind in school, especially since the majority of students in the US are very visual learners. And that is the precise problem we attempted to solve with opennote. With opennote, we aim to cater directly to students, educators, and learners alike, and help cater to visual learners and be able to take any form of notes that they may have and visualize it into any format and make it much easier to digest and be successful.
You'll be launched into your Spaces page, which lets you access all of your pages and all of your workspaces that you generate as you use the application. Through the dashboard, you can delete your pages as well as open new spaces or create a new one entirely on your own. When you prompt it to create a new page, you can give it a name and you can pick between handwritten and typed notes. Once that space is created, you'll get launched into our dashboard window. All of these routes are authenticated, meaning that no other users can get onto your spaces, as well as the fact that no other users can access your files because they're all linked to your workspace. Now what we can do is we can generate our first video and help us learn. What I have here is a set of notes that I took in a linear algebra class earlier. And what I'm going to do is I'm just going to upload that, and I'm going to ask it to generate me some content. So I'll say, please teach me the material in the notes provided, as I had to miss lecture earlier. And now we can send this message in. You can see that the opennote AI will start loading. Once you request the data, it is sent to our backend API, which is Random Class API in Python. As you can see here, Google Gemini parses out the content of any supporting files that you provided, and then it gives you a bunch of training data for ChatGPT or OpenAI's GPT-4 model, which then parses out data from these sources and learns from its system data, as well as taking content from other various sources such as image processing and byte string processing. All of these are then put together to create a final prompt, which then generates your video. As you can see, GPT has now created its first parse of the video, so it's basically set it up in Manum. Now the issue is that sometimes LLMs aren't perfect. As such, we've implemented an error analysis system that takes the error of the build of our animation and sends it back into the model, which then lets you generate new code based on any errors that are written. These errors are parsed by Google Gemini's 1.5 Pro model, as well as the PDFs that we parsed earlier were also on Google Gemini 1.5 Pro. Once Manum is done generating, it'll add a text-to-speech client to the video, which is then put together by FFmpeg, which mashes the MP4 and MP3 files together to get you the audio output that you want.
In this video, we delve into the concept of subspaces of math R end. We begin by defining a subspace H and discussing its properties, such as closure under addition and scalar multiplication. Next, we explore the idea.
Once this is completed, any of your videos that are saved to your workspace will then show up down here, as well as the fact that you can talk to any LLM that's on the backend, which is our Gemini chat client, to gain more context on your video. An example is shown. When files aren't provided in your chat query, it is immediately parsed as a text request to our chat client on Google's Gemini.
In this video, we delve into the
which then gives you this output.
In terms of future plans we'd like to implement in our app of opennote, we'd definitely like to implement this auto-recursive code generation towards our Manum animations. That way, if there are any inconsistencies or slight mishaps in the Manum animation, as these generative AIs are great, but not always perfect, as we know, this would be really useful to kind of make everything automated and make the whole system more streamlined to get more accurate and, I guess, useful animations for people to use every day.
Besides that, we also want to scale the application to as many users as possible. We'd like to optimize our backend requests and LLM optimization pipeline, meaning that we'd be using less clients, less requests, and being more efficient with how we handle our data. This would also open up more venues to opening this app up internationally and even to multilingual spaces. Thank you for your time.